All right, in this video, we are going to work problem 4.184 from our book about governors. It says the National Governors Association publishes data on U.S. governors and governors' political affiliation in terms of office. Based on that document, we obtain the following frequency distribution for U.S. governors as of 2013. All right, so here they list the party and then the frequency. All right, it says 2 U.S. governors are selected at random without replacement. Find the probability that the first governor is Republican and the second is a Democrat. Okay. All right, so we want the probability that the first is Republican and the second is Democrat. All right, so we want to calculate the AND of these two events. We can use the general multiplication rule. So the general multiplication rule says that is equal to the probability that the first governor picked is a Republican times the probability that the second governor picked is a Democrat, given that the first governor is Republican. All right, and on the first one, the Republican, we have 50 governors, right, total, and 30 of them are Republican, right? So that would be 30 over 50. And then for this conditional probability, we assume that the first governor has already been picked and a Republican was picked. And so that means that there will be 49 governors left, right? Because the governors are picked without replacement, right? So you can't pick the first one or can't pick any of them twice, right? So now we only have 49 governors to pick from, and then assuming that the first one is Republican, we want to know, hey, what is the probability that the second one is a Democrat, right? And so that will be 20 because there's still 20 Democrats there, okay? And so that comes out to be 600 over 2450. All right. Part B, find the probability that both are Republicans. All right, so we want the probability that both are Republicans. Again, what you want to do is rephrase that event to use one of the operators. In this case, it's going to be AND, right? Because the fact that they're both Republicans means that the first one is Republican and the second one is Republican. All right, and this is a lot better, right, to have in this format because we have a nice formula for dealing with calculating that probability. That's the conditional probability formula. So the conditional probability formula says that the probability of the AND of these two events is equal to the probability that the first one is a Republican times the probability that the second governor picked is Republican, given that the first is Republican. Okay? All right. So, the probability that the first one is Republican is 30 out of 50, right? At that point on the first draw, there's 50 governors picked to be that can be picked. So our sample space has 50 governors in it. And then the event, the first one's Republican, there's 30 ways, right? There's 30 Republicans to choose from at that point. All right, and now calculating the conditional probability, we want to calculate the probability that the second governor picked is Republican, given that the first one picked is Republican. All right, so we've already picked the first one, so that will mean there's 49 governors left. And we're also assuming that the first governor picked is Republican, right? So that means that there will be 29 Republicans to choose from, okay? Because the first one was picked was a Republican. All right, and so then that will be 2450 and 30 times 29, 870. Okay. All right, in part C, they want us to draw a tree diagram for this problem similar to the one shown in our book here. All right, and so what you would do to draw this tree diagram, I gotta make sure that I'm leaving a space here. That's probably not enough, so let me move down a little bit. So how I would start off is that I pick, here I show the possibilities for the first pick. Right, I pick one of the governors. On the first pick, they're either Democrat or Republican. And then what I want to do is calculate the probability of that. So the probability of a Democrat would be 50, 20 over 50, I think that's right. And the probability of a Republican would be 30 over 50. So I just draw the probability here. All right, and then in the next stage, I can do that again, right? So this shows the second stage, okay? That the second pick is a Democrat, right? After the first one picked has been a Democrat. And then what you would do is put the conditional probability, right? You would assume that this event has already occurred in the first round. And so what would be the probability of picking another Democrat in the second round? Well, there'd be 49 governors altogether, right? And there would be 19 Democrats left, okay? And then for Republicans, right, what I would do, again, these are going to be conditional probabilities that I would put on the second stage. So what is the probability of picking a Republican in the second round, given that a Democrat has already been picked in the first round? That would be 30 over 49, right? Because a Democrat was picked, there's still 30 Republicans out of 49 governors. All right, and then do that again. And again, what I'm going to do is label these branches on the second part of the tree as conditional probabilities. So the conditional probability that you would pick a Democrat in the second round, given that you picked a Republican in the first round, would be 20 out of 49, right? 49 governors total, and 20 of those are Democrats. And then for Republican followed by another Republican, that would be 29 out of 49. 49 governors left total, 29 Republicans left. So the probability of picking a Republican in the second round, given that a Republican was picked in the first round, is 29 out of 49. Okay? So this gives you every possible thing in your sample space, right? And you can list that out. So here would be DD. So I'm getting that just by starting here at the root of the tree and following along each path that I can go. So if I follow up here, I get 2 Democrats picked. If I follow here, Democrat and Republican, right? That's the outcome there. If I follow along here, I get Republican, Democrat. And if I get Republican, Republican, if I take the lower branch all the way, right, down here. All right, and then what I can do to get the probability, right, of these events here, I multiply along the path. So the probability that the probability of picking two Democrats, right, would be 20 times 19, 20 over 50 times 19 over 49. That comes out to be 380, I believe. Okay. Then the probability of getting a Democrat on the first draw and a Republican on the second draw, right? Again, you would multiply these probabilities like this. And if you think about that, that's just that general multiplication rule that we're doing there. So that would be 600. Oops, I'll just go ahead and write it out. That would be 20 over 50 times 30 over 49. Right, because 20 over 50 times 30 over 49, that comes out to be 600 over 2450. All right, and then a Republican on the first round and a Democrat on the second round. That's actually the problem that we did in part A. Right, you can see it's coming out exactly the same way because these are conditional probabilities, right? And so we get 600 over 2450. And then Republican, right? That would be what we got in part B, right? Following along that path, it'd be 30 over 50 times 29 over 49. So 30 over 50 times 20 over 49. Or sorry, 29. So that is 870 over 2450. All right. So that's how you would make the tree. Once you make that tree out, you can see it's you can kind of look at those probabilities that you have on there and figure out some probabilities of events pretty easily if you take the time to make the tree first. You don't have to, like we showed here in parts A and B, but now that we've made this tree, we'll use it for parts of D and E. Okay, so that's part C. All right, in part D, they want to know what is the probability that the two governors selected have the same political affiliation. All right, so I'm going to work it first without the tree, and then we will look at the tree, right, and see how we could have gotten our answer from the tree. All right, so this is part D. So probability that the two governors selected have the same political party affiliation. So probability, same party. All right, so again, what you want to do is this writing it as same party tells you what it is, but it doesn't really help you calculate it or know which rules to calculate it, right? So what you would have to do is to write that using one of the connectors that we've already talked about. And so just think about what would it mean to be the same if they're both picked to be the same party? What's another way of saying that? Another way of saying that, right, would be that they are both Republican or both Democrat. Okay? So that's a little bit different than the problems that we've been working at here. Okay? So the probability that that they are both Republican or both Democrat, we need to use the addition rule, right? One of the addition rules, because that's how we calculate the OR of two events, right? And so remember back when we did that in the previous section, right? The first thing we did was try to decide, are these events mutually exclusive, right? And we were kind of hoping that they are mutually exclusive because that's a little bit easier, right? If the events are mutually exclusive, then you can use the special addition rule. If not, you have to use the general addition rule, right? So we ask ourselves, is it possible that when we pick two governors, right, that they're both Republican and also at the same time they are both Democrat? And the answer is no, that's not possible, right? If they're both Republican, well, that means they're not Democrats, right? And if they're both Democrats, that means it couldn't be that they are both Republicans. So these two events are mutually exclusive, okay? And so what we can do then is to use the special addition rule. And the special addition rule says if I have two mutually exclusive events, right, and I want to calculate the OR of the two, all I need to do is to add their probabilities together, right? So this probability is that they're either both Republican or both Democrat, okay? All right. And if you look, we've already calculated these probabilities here, right? We calculated the probability that they're both Republican, right, up here in part B. So we have that already. So we know the probability that they're both Republican is 870 over 2450. And then the probability that they're both Democrat, we could do exactly the same way, right? That the first is Democrat and the second is Democrat. We would use the generalized addition rule, but we have this tree right here. So what's nice about the tree is we've already done all of that work. So the probability that they're both Democrats, right, is this event right here, that they're both Democrats. And so that would be 380 over 2450. All right, and that comes out to be 1250 over 2450. All right, and that looks all right. All right, then the next parts, the last part, is what is the probability that the two governors selected have different political party affiliations, okay? All right, and so we can do that a number of ways, right? We could do it using the complement rule, right? It's actually going to be 1 minus, right, this probability here, because, right, what's the complement of the same party? That's that they're different parties. So we could do it that way, right? Another way we could do it is, right, we want to know what's the probability that they're different parties. We could do it very similar to the way we just did it, right? The probability that they are different parties is equal to the probability that the first is Republican and the second is a Democrat, or that the first is a Democrat and the second is a Republican. Okay? So, again, using the fact that those are mutually exclusive, right? We have the OR of these two events here, right? The OR of this event and the OR of this event. What we would do is ask ourselves, hey, are those we need to calculate the OR of those two. So we need to ask ourselves, are these two events here on either side of the OR, are they mutually exclusive? And the answer is yes, they are, right? And just ask yourself, is it possible that the first governor drawn is Republican and the second is a Democrat? If that happens, is it also possible that the first governor drawn is a Democrat and the second is Republican? And the answer is no. Those two things can't happen, right, with the same outcome, right? Because if the first governor picked is Republican, that means they're not a Democrat, right? And so that those two can't happen. So these two events are mutually exclusive, right? And I can write this as the probability that the first governor is Republican plus the probability, and the second governor is Democrat, plus the first is a Democrat and the second is Republican. So the probability of those two things, okay? So now we would need to calculate the probability of this event here. We could do that just like we did in part A and part B. Using the general multiplication rule, and same thing here. But again, we have our tree, right? And we've essentially already done that, right? So the probability that the first is a Republican, the second is a Democrat, right? We calculated that right here, and we found that that was 600 over 2450. And then probability that the first is a Democrat, second is a Republican, right? We got that that was 600 over 2450 as well, right? And so that's right here. And we can add that together and get 1200 over 2450. Okay, and so that's one way to calculate E. I just wanted to show that way because there's some problems where you kind of have to do it this way, and I think it's good if you see an example like that. If I were working this, I probably just would have said that use the complement rule, right? The probability that they're different parties, that's equal to 1 minus the probability that of the same party, right? Because if they're not different parties, I guess I could add that extra step in there. That's the complement rule, right? That says the complement, right, is the probability of the complement is 1 minus the probability of the event, right? And so if they're not different parties, right, that means that they're in the same party in this case. And we already have that probability, right, which was 1250 over 2450. So that's going to be 2450 over 2450 minus 1250 over 2450. Now you can see that that is going to come out to be exactly the same number that we got here. 12, oops, not there, but a little bit lower down here. So that comes out to be exactly the same number as in part E. So you could have done it this way. I just wanted to show another example where we had to use both the a rule for addition with the OR and with an AND as well. All right, so that's it for this one.